This video is going to focus on polynomial function basics. The two main parts that we're going to be talking about today are what are the degrees of a polynomial function, and then what is the notation for a polynomial function, what does it look like, and how can you use that notation to help you solve it. So with that said, let's jump into what the degrees of a polynomial are. Here we have the polynomial x squared plus x minus 3. What makes this a polynomial is that we have more than two terms. As you notice, we have an x squared term, an x, and a minus 3 term, so there's 3 there. As long as you have more than two terms, it's a polynomial. If you only have two terms, it's a binomial. The other thing that makes this a polynomial is the fact that there's only one variable. We use only the letter x, and our exponents are positive. There's going to be no division by exponents in a polynomial. So with that said, we want to know what is the degree of this polynomial. And that is a really easy question to answer. The degree of the polynomial is based on the largest power on our exponent. So since I have x squared here, this is a second degree polynomial. And we can check that because our other x, well, there's no exponent on it, so that means it has an exponent of 1. 2 is greater than 1, so this is a second degree polynomial. All you have to do to find the greatest degree is look at the exponents and find the biggest number. Not too hard. Let's look at another one. Here we have the polynomial 5 minus 3z plus 8z squared minus 4z to the third. And if you notice, it's in a little bit different order. Normally we have the highest exponent here and the lowest or constant over here. So we have to kind of hunt through the problem to find our highest power. And hopefully we see, oh, it's z to the third. So what degree does that make it? It makes it a third degree polynomial. Now we can also talk about something here that'll come up in a later video of something called a leading coefficient. And if we remember, the coefficient is the number that's in front of a variable. So I've got a coefficient of a -3 here, I have a coefficient of an 8, and I have a coefficient of a -4. Well, the leading coefficient is just the coefficient that is on the variable with the highest power. So since this is z to the third, its coefficient is -4, so the leading coefficient would be, you guessed it, -4. Now, it's always good to know this. We'll talk about this more in a future video, but there you go. Now, let's look at this next problem and see if we can figure out, one, if it's a polynomial, and if it is, what is the degree? Here I have 2a squared minus 3b squared a minus 4b. The question is this a polynomial? Well, hopefully, based on the definition I gave at the beginning of this video, you're shaking your head saying no. And the main reason for that is I have an a and I have a b variable. The fact that I have two variables here tells me it is not going to be a polynomial. A polynomial can only have one variable. So we would just have to say not a polynomial. Let's look at one more example. Here we have a plus 1 over a. Is this a polynomial? You might start off by saying yes, because we have just the letter a. But this brings in the other part that I mentioned at the beginning of the video, that you cannot divide by a variable in a polynomial. Or, another way to think of it is, you cannot have a negative exponent. So if I were to rewrite this, I would have a to the first, which is positive, plus a to the negative first. And the fact that I have this negative right here, it's not going to be a polynomial. So that's how we find the degrees and we decide if something is a polynomial. Now let's move into some functions, looking at the notation and how to solve for them. Here we have a function, p of x equals 5 plus 4x. And this is the notation that you will see in many functions. Specifically, this part right here. You've got a letter, and then you've got a variable inside parentheses. This is the function p, and our variable is x. And then this is what the function is made of. Whatever x is, multiply it by 4, and then add 5 to it. Think of it kind of like a vending machine. You put money in, you push some buttons, and you get something out. Same thing with a function. You put in the value for the variable, you do your operations, and you get an answer. Now you might see stuff that looks like this. We're going to use function p right here, and it might say, oh, I want to know what p of 2 is. Well, the way we solve this is we take our function from here, we take our x variable, and we put 2 in its place. So this would become 5 plus 4 times 2, which would equal 5 plus 8, which gives us the answer of 13. So p of 2 equals 13. Okay, and if they were to say, oh, let's try, give me a moment to erase this. I want p of negative 7. P of negative 7. Well, it's still using this p function. So we will have 5 plus 4 times negative 7, which is 5 minus 28, which gives us negative 23. So when we have our inputs here, they can be positive or negative. They could be decimals, they could be fractions, anything. You're just plugging it in to our variable right here. But what if what they give us for the variable here isn't a number at all? Or what if they add some other sort of modifier to the function? Let's take a look. So here we have a new function. We're calling it function r. This function is 4x squared minus 2. And look what they're asking us to find here for this first one. We want to find r evaluated at a. Well, that seems weird. I have an x. I don't have an a. Well, actually, it's pretty simple what we're going to do. We're going to take our function, and wherever we see x, we're going to put in an a. So this would just become, this would just become 4a squared minus 2. And that would be our answer. All we had to do was plug in a for x. This one's similar. We've got an m squared this time, which we're going to have to use some of our exponent abilities. But then you notice I've also got a 3 in front of that. Well, first let's take care of this. Let's do our inputting with the m's. So that's going to give me 4 times m squared, and we got to put this here. Because look, it's x squared, and what I'm putting in for x is m squared. So here's where x was, and we have to square it. So we're going to have to take care of that in a moment. Nothing happens to the minus 2. So this is going to be 4m to the 4th minus 2. But don't forget about the 3 out here. This tells us we're taking whatever the function of r evaluated at m squared is, and we're tripling it. We're multiplying it by 3. So I have to take all of this and multiply it by 3. So our final answer, or evaluation of this function, is going to be 12m to the 4th minus 6. And there we have it. We've got some function notation. We've learned how to evaluate it when we're told to put in a number or a variable, and what happens if we're being asked to scale that function. So hopefully you found this helpful, and good luck.